Hello, everyone. Welcome to our lectures. My name is Daniel from Huawei Global Training Center. This is the first chapter of our course, which is about the big data development trend and the Kunpeng big data solution. Okay, before jumping into the main lecture, first we can have a look at the objectives of this chapter. We hope that after finishing this chapter, you can be able to understand the definition of big data, some opportunities and challenges in the big data era, the development trend and application of big data technologies, and be familiar with the Huawei Kunpeng solution as well as the Huawei Big Data solution. Okay, firstly, a comprehensive introduction to big data and big data era. Honestly speaking, we are currently in the fourth industrial revolution, which is leading us to the intelligent era. Before this era, we have experienced many industrial revolutions as shown in the slide. Like in the 1760s, the UK took the lead in launching the first industrial revolution, bringing the world into the age of steam. As a result, the UK became the first industrialized country in the world and brought a series of social changes. In the late 1860s, the second industrial revolution began. With the large-scale application of AC power, we entered the age of electricity. The third industrial revolution is marked by the invention and application of atomic energy, electronic computers, space technology, and bioengineering. It is a revolution of science and technology involving many fields such as information technology, new energy technology, new material technology, biotechnology, space technology, and marine technology. The United States has gradually gained its power during the third industrial revolution, also known as the information revolution. The fourth revolution of science and technology is unfolding with the convergence of new IT technologies such as cloud computing, big data, IoT, and AI. Those who can respond to the core of the era will become the trendsetter. In addition to the industrial revolution, operators need to transform their main sites to adapt to the digital and information era. Under such circumstances, we need to move from data management to data operations. Here, we can see three sentences. Firstly, data drives experience. Have you heard of the recommendation system? Actually, this is how Amazon makes money. For example, I have been searching for cookers for a while on Amazon, and next time I log into it, I would be most likely advertised with some frying pans or even some teapots, right? So just like this simple example, enterprises like Amazon or YouTube label the users based on their behaviors and features. And all the behaviors and features are nothing but data. Secondly, data drives decision-making. There is another example. As is known to all, there are many oil fields in the Middle East, right? But how do they determine where is proper for digging oils? Again, based on the data. But now, they mainly rely on the historical data, like data for the past 50 years, and based on some technical methods like data mining and data visualization, we can make decisions more easily and more convincingly. Thirdly, data drives processes. We are currently in the big data era, and every process involves many types of data collisions. Like we pay for our lunch by credit cards or by mobile phones, or like transferring money to our friends in the bank. Almost everything now requires data flowing efficiently, and also we can use big data methods to help us simplify all the processes as well. Alright, so nowadays, we keep talking about big data all the time. But what is big data? Actually, no one can give a certain definition. From Wikipedia, big data is data sets that are so large and complex that traditional data processing application software is inadequate to deal with. But is that all about big data? Here, we'll give you 4 V's for description. These 4 V's are developed on the basis of the 3 V's originally issued by IBM, and now it is widely accepted in big data industry. To be more specific, the 4 V's are actually 4 features of big data. The first V is the volume. And of course, the volume of big data must be enormous. Does anyone know the units of the data measurement? Commonly, we will use byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, etc. to describe the data volume, right? And in general, we call the data as big data when the volume is above terabyte. And to give you a direct impression, there is an example. Basically, an SD movie lasting for 1.5 hours is about 1 gigabyte. So, if you download more than 1,000 movies at the same time, you can say you are dealing with the big data. Okay? Alright. The second V is variety. And in big data era, we need to process data of different types. In general, the data can be divided into 3 types: structured data, semi-structured data, and unstructured data. Structured data usually resides in relational databases as 2-dimensional tables. And in a databases, we have fields which store length delineated data like phone numbers, social security numbers, or zip codes, etc. And unstructured data includes pictures, videos, and audios, etc. Or namely, unstructured data either does not have a predefined data model or is not organized in a predefined manner. And the semi-structured data mostly refers to the web page files in HTML, XML, YAML, or JSON formats. Okay, the third V is velocity. From the result of the research, the data we generated in the recent 5 years is much more than the data generated in the past 5,000 years. So the explosive growth of data requires us to increase the velocity on dealing with this information. The fourth V means value. All of the data is valuable according to different applications. But the volume of data is huge. Maybe only a small part of it are useful for handling a specific problem. To some extent, the original data is like fossil oil, which needs to be extracted or processed, just like the oil should be refined from petroleum. As we all know, fossil oil is vital in our society, but it just consists of a very small proportion of the raw petroleum. So, as shown in the slide, we can use the 4 keywords to describe big data very well, and this is actually the most widely accepted definition for big data. So what are the differences between data processing in the big data era and the traditional data processing? Here, we can use an analogy to introduce their differences. The traditional data processing is like fishing in the pond, while big data processing is like fishing in the ocean. And to be more specific, we can draw a table as follows. Firstly, the volume of big data is huge, and in most cases, we have to deal with data in at least terabyte level. While in the traditional data processing, the data are usually scaled by megabytes or gigabytes. Besides, the variety of big data is more than traditional data. Since now we got structured data, semi-structured data, and unstructured data in big data analysis. While in traditional data processing, there is mostly structured data in relational databases. Moreover, in the past, we got used to generating the mode of data processing before finding data which fits this mode. By contrast, nowadays, we get the data first, then come up with different models to deal with the data. And meanwhile, keep the models evolving when data increase. For the objective of the data processing, the goal of traditional data processing is to analyze the data and get some existing information or regularity from the data we have. But the big data processing is to predict the future. So in order to make our prediction as accurate as possible, we need many machine learning or deep learning algorithms for help. And finally, for the processing tool, traditionally, we can use relational databases to process all the structured data. But now, in big data era, data have more variety, and the processing tool also varies a lot from batch processing to stream processing.
Okay, that's all for the big data era. Next, we can have a look at the big data application fields and some computing tasks for big data.
pie graph on the right is the market scale proportion of big data market segments.